People have forever been energized by the possibility of other living things outside our home planet, Earth. For many years, space researchers and space travelers have devoted long stretches of examination to find if really life exists outside the green planet, and presently they could possibly have found something mind-blowing. The James Webb Telescope, quite possibly one of the most astounding space innovation apparatuses as of late, noticed bizarre city lights on an exoplanet trillions of miles from Earth. Are these city lights proof that life indeed exists outside the green planet? Don't take your eyes off your screen, because what we're going to reveal will blow your mind. The James Webb Telescope's new discovery since its launch in 2021, the James Webb Telescope, usually known as JWST, has acquired a standing as a monstrous supporter of our insight into the universe. The JWST was made to light from the primary stars and universes that shaped after the enormous detonation. It was moreover made to concentrate on how systems structure and change over the long haul. The logical community was as of late shaken when the JWST saw obvious proof of life in space while investigating space and sending fundamental information back to Earth. The telescope distinguished bizarre lights that seemed to be city lights on the exoplanet Proxima Centauri b. When researchers inspected these city lights, what they found was beyond whatever they might have at any point envisioned. These lights appear to look like those of a distant city. The thought that an outsider city could exist on this star has flabbergasted researchers, as it could be the verification they've been looking for. Assuming that this is valid, it implies smart creatures are making civilizations in space that people are only now discovering. As NASA designers check out the city lights 7 trillion miles away, they can't resist the urge to consider how long these lights have been shining, pausing for people to foster the innovation to see them. David Kipping, a cosmologist from Columbia University, depicts the exoplanet Proxima Centauri b, where the city lights were viewed as trying to concentrate on this is on the grounds that the star framework closest to us, Proxima Centauri, has strange warming examples dissimilar to other planets. Ordinarily, rocky planets absorb sunlight and transmit infrared radiation, but Proxima Centauri b acts differently in its infrared emissions than its host star. The JWST is suitable for this task since it can undoubtedly identify infrared frequencies. Because of the JW's high-level infrared imaging technology, Proxima Centauri b's exceptional intensity mark will assist researchers with learning about its climate. Researchers plan to utilize the telescope to reveal the secrets of this planet's climate and assess the potential for life there. The JWST's infrared responsiveness is ideal for investigating what occurs on Proxima Centauri b's night side. While getting weak light in space is generally hard for telescopes, the JWST can distinguish even the smallest beams. This makes it the ideal apparatus to affirm if there are indeed city lights on Proxima Centauri b's night side. Proxima Centauri b has a unique interaction between its star and its surface. As Proxima Centauri b circles its star, it encounters constantly cycles like Earth with hot days and cooler nights. The planet's temperature changes relying upon its makeup. Without a climate, the temperature difference among constantly would be extreme. Without climatic gases and seas, the day side would bubble while the night side would be cold. Stargazers concentrate on these temperature varieties to better comprehend Proxima Centauri b's climate. JWST, with its high-level infrared imaging, can inspect the planet's warm outflows to give valuable information about its atmosphere. Interestingly, the JWST's circle around Earth lines up with Proxima Centauri b's orbital period, permitting it to notice the planet's complete day and night cycles every 11.2 Earth days. Space experts are presently zeroing in on ground-based observatories like the Incredibly Large Telescope, normally called the ELT. They said we can't see sufficiently far, so we want a greater telescope that is more touchy and that can look at longer infrared frequencies so that we can see the more far-off universe. The ELT, set to begin in 2028, will look at the atmospheres of far-off exoplanets, giving detailed information on their livability. NASA researchers and others enthusiastically anticipate such future telescopes. In the interim, the JW remains significant for considering far-off exoplanets. Despite its limitations, the JWST can offer enormous insights that could change our understanding of exoplanet investigation. Future space telescopes point to reduce the brilliant light from a planet's host star so that the planet can be better seen. This could be done utilizing inside veils or enormous outer satellites formed like umbrellas. Like shading your eyes to see better by darkening the star's light, these telescopes will all the more effectively concentrate on faint reflections from exoplanets, taking into consideration a more direct examination of their airs and potential for life. But this approach has a lot of challenges associated with it. Scientists must distinguish between gases produced by life and those from geological processes like volcanic activity. After laying out that the planet has air around it, it is essential to check assuming it is really good for life. We can do this by searching for specific gases like oxygen, water, and methane. If we find these gases, the planet could potentially support life. To do this, researchers need to be very cautious and study the light that goes through the planet's air. But this is not an easy task. The James Webb Space Telescope is truly adept at examining the air around planets. However, it's generally intended to check out water vapor, carbon dioxide, and methane. It's not as good at finding oxygen, which is a fundamental evidence that something is going on under the surface. Anyway, it can still look for different indications of something going on under the surface, like ozone, which shows how sound the air is. Remember, the James Webb Space Telescope can take a gander at a couple of planets that are near Earth and could possibly uphold life. Stargazers are as yet endeavoring to get more familiar with exoplanets like Proxima Centauri be outside our nearby planet group to better recognize indications of something going on under the surface and tell them separated from phony problems. JWST shows forthcoming logical leaps forward in concentrating on these planets, providing us with a brief look at the thrilling revelations ahead. As we grow our information and investigation of the universe, we get a clearer comprehension of how it functions and our place in it. Following quite a while of considering these exoplanets, have researchers seen as any with life yet? Continue to watch because we'll uncover what they found in the next piece of the video. Life on exoplanets. The presence of life on exoplanets. As we previously established, exoplanets are planets that circle stars other than our Sun. Huge numbers of exoplanets have been tracked down utilizing strong telescopes. Some of these planets may be similar to Earth and have the right circumstances for life. Researchers use telescopes like JWST to check stars out and check whether there are any little movements or diminishing of light. These changes can mean a planet is passing before the star. By considering these movements, researchers can tell how giant the planet is and the way that far it is from its star. Right now, we only know that life started on the planet. Assuming we track down life somewhere else, we can contrast it with life on Earth. Motivation from such revelations can drive the up-and-coming age of researchers and pioneers. These revelations can likewise address philosophical and existential inquiries regarding our place in the universe. Are we alone, or is life normal? Addressing these inquiries can change how we view ourselves and our part in the universe, giving another perspective on humankind's importance. The quest for life on exoplanets pushes researchers and specialists to foster new advancements. These innovations regularly have other beneficial purposes on Earth, for example, better telescopes and instruments. Work on our capacity to concentrate on the universe and progressions made in space exploration can lead to innovations that benefit other fields. Studying other planets can likewise enhance our comprehension of Earth by comparing Earth to various universes. We find out more about environment geography and how planets change over time. This comparative planetology can lead to better insights into Earth's processes and future. In spite of how hard they're looking, researchers still haven't had the option to track down life on these planets due to many challenges. One big challenge is that exoplanets are very far away, sometimes hundreds or thousands of light years from Earth. This significant stretch makes it hard to concentrate on them, since light from these planets consumes most of the day to contact us. Even with strong telescopes, seeing details on these far-off planets is difficult. Another challenge is the small size of exoplanets compared to their stars. Stars are exceptionally bright and can, without much of a stretch, dominate the light from their planets. This makes it hard to see exoplanets directly because their light is weak and often concealed in the glare of their stars. Scientists utilize special techniques like shutting out the star's light or searching for small wobbles in the star's movement to find exoplanets. Shutting out the star's light can assist with uncovering the faint light of the exoplanet, while noticing wobbles in the star's movement which can show the gravitational pull of an or circling planet. These techniques, known as travel photometry and radial velocity, have been effective in finding a large number of exoplanets. However, they are not without difficulties and can miss smaller or dimmer planets. Some exoplanets may be too close to their stars or too faint to be detected with current methods, posing an ongoing challenge for astronomers. However, things do not end there. There is also the issue of the assortment of exoplanets. These planets come in various types with diverse sizes, temperatures, and compositions. For example, some exoplanets are scorching hot, while others are cold. Some have thick climates that could uphold life, while others have no air at all. This variety makes it challenging for researchers to pinpoint where to look for life. Thus, researchers often focus on planets that are similar to Earth, since Earth is the only known planet that supports life. However, this approach has its limits. Life could possibly exist in conditions very different from Earth's, like on planets with extreme temperatures or unexpected chemical compositions. If we only search for life on Earth-like planets, we may overlook entirely different forms of life that could thrive in conditions we currently consider hostile. Researchers also face the challenge of analyzing the vast amount of data collected from exoplanet studies. Telescopes and other instruments can gather a lot of data, and it takes a lot of time and effort to analyze this data. Scientists need to develop new techniques and utilize powerful computers to process and understand the data. This requires collaboration between many scientists and specialists from different fields, which can be challenging to coordinate. Evidence of life outside Earth. Evidence that life exists outside Earth has always inspired people. People have always believed that some sort of living thing outside Earth is ready to be found. To prove that this existence of vast life is genuinely, in 1984, two American stargazers, Jill Tarter and Thomas Pearson, started the Look for Extraterrestrial Insight organization, otherwise known as SETI. This charitable project aims to investigate grandiose transmissions to detect radio transmissions from space. Radio transmissions are desirable because they can travel significant distances without getting dispersed or absorbed like other forms of radiation. Due to this property, radio transmissions are likely to be detected by the 42 radio telescopes of the Allen Telescope Array in the Fountain Piles of California. For more than 30 years, the SETI organization has been searching for signs of alien life by searching for radio transmissions from space. These signs are a form of communication that could indicate the presence of intelligent creatures outside Earth. Despite many years of effort, such signals have yet to be found. However, scientists at SETI, including Jill Tarter, remain hopeful. They trust that with new and better technology, they can speed up the search and ultimately find proof of extraterrestrial life. When they made SETI, Jill Tarter and Thomas Pearson did so in a bid to prove that life exists beyond Earth. SETI is a charitable organization dedicated to investigating the sky for radio transmissions that could come from intelligent alien civilizations. The reason they focus on radio transmissions is that these transmissions would be able to travel significant distances through space without getting dispersed or absorbed, unlike other types of radiation. This makes radio transmissions easier to detect with telescopes. The SETI Foundation uses an array of 42 radio telescopes called the Allen Telescope Array located in the Fountain Piles of California. These telescopes work together to listen for faint radio signals from space. Researchers at SETI have developed sophisticated methods to analyze these signals and filter out noise from other sources like human-made signals and natural cosmic noise. They are looking for patterns or anomalies that could indicate intelligent communication. One of the main challenges in finding alien radio transmissions is the vast distances between stars and planets. Many exoplanets, which are planets outside our solar system, are hundreds or even thousands of light-years from Earth. This means that any signal sent from these planets would take a very long time to reach us. Moreover, the signals could be very weak when they arrive, making them difficult to detect. The search for extraterrestrial intelligence also drives technological development. The instruments and techniques developed for SETI have applications in other fields, such as advancing communication technologies and improving how we can decode the universe. The search for alien life has led to the creation of new algorithms for data analysis, advancements in signal processing, and the development of other strong telescopes, just like we mentioned at the beginning of this video.